Today we'll see how to go in for a time series analysis when number of years happen to be even. As we discussed last time in the other video, that time series analysis using method of least squares is very easy when you have odd number of years, data for odd number of years. But as soon as this data becomes for even number of years, then it becomes a bit cumbersome. Let us see what happens. We have years and we have sales figures in thousands, okay, and the data is so here we have our data. Now let us discuss what happens for various combinations. Suppose we take this as our reference point, then what happens? 2014 becomes +1, 2015 becomes +2, and on downward side we have -1, -2 and -3. Now if I go ahead and call this as my x, then when I will sum it up, I'll get -3, and if we get a -3, then the purpose of using deviations is lost, because the purpose was if sigma x becomes 0, a lot of values will become 0 and the simultaneous equations get solved easily. So the purpose over here is lost. So let me think of some other philosophy or a workaround, and that workaround would be, why not take the middle point as reference point, middle point, that is between 2012 and 13. So that will become my 0 point, and this 2013 would be half a year more than that, so it will be 0.5, and from this reference 2014 would be half and 1.5 more, and 2015 would be 2.5 more, and on the downward side similarly it will be half, but on negative side -1.5 and -2.5, and when you sum it up you'll get your 0. So sigma x would be 0. So this looks like a good proposition, but problem is 2.5, 1.5, these are practically, mathematically these are literally like 25 and 15. For calculation's sake they will act as 15 and 25. So we have not eased up our calculations now, but definitely I am getting the sigma is 0. So now what I'll do is I'll go a step further and multiply all these values with 2. What that does is 0.5 multiplied by 2, 1, 1.5 multiplied by 2, 3, 2.5 multiplied by 2, 5. So my 1 year is being represented by 2 units of deviation. That makes perfect sense. No issues with that. 1 year is equal to 2 units in deviation. So this becomes -1, -3 and -5. Now when we take square of 5 or multiply it to 93, it still remains a simple value. So here we have a rule for us that whenever we have even number of years, we will take these as deviations. What are these? The middle two values go down as -1 and 1, and the remaining values move by a deviation of 2, 1 to 3, 3 to 5, -1 to -3, -3 to -5. So this is what we'll be using here. Now let us get rid of this and have our actual x value with us. Okay. Now, so finally we have decided that yes, I'll represent sales with y, and instead of representing this as x, I'll go with deviations. Deviations here are x this will become 1, 3, 5. Downward side I have -1, -3, -5. So I have y, I have x. I'll be needing xy and I'll be needing x square. And then I'll be needing summations of all these values. Okay. xy would be 40 multiplied by 5, that is -200. Okay, so these are values of xy and x square. And now let us find out summations of all these. Sigma of y, sigma of x, sigma of xy, sigma of x square. So sigma of y would be 360. Sigma of x would be 0. Sigma of xy would be 348. And sigma of x square would be 70. Now that we know our regression equation is y is equal to a plus bx. This is my regression equation. And in order to find out values of a and b, what do? We solve a couple of equations simultaneously. And the equations are sigma y is equal to na plus b sigma x. And the other one becomes sigma xy is equal to a sigma x plus b sigma x square. So these are the two equations that we solve simultaneously to get values of a and b. Let us go ahead and solve them. Sigma y is 360. So this equation becomes 360 is equal to na. N is number of pairs. So here I have 1, 2, 3, 4, 5 and 6. 6a plus b sigma x. Sigma x is 0. So b gets multiplied to 0 and for all practical purpose this is 0. So can I solve this? 360 is equal to 6a. So a becomes equal to 360 upon 6, giving me a value of 60. So my a in this case is 60. Okay. Now let me get on with my second equation. Second equation is sigma xy. Sigma xy, that is 348 is equal to a sigma x. A sigma x again is 0. So when anything is multiplied to 0, this will reduce to 0. But still I have another term bx square. B sigma x square. Sigma x square is 70. So I have 70b. Now as this is 0, I get 348 is equal to 70b. So my b comes down to be 348 upon 70, which gives me 4.97. This is value of b. So now can I have my equation? My equation, regression equation would be y is equal to a, that is 60, plus bx. B is 4.97x. So by now you should be knowing that when I say that this is my solution or this is my equation, I mean what are these coefficients a and b. I substitute values of coefficients a and b. That is my solution of a regression equation. Now suppose you were asked what are the expected sales in 2017. So what I'll do, I cannot put 2017 over here in place of x because I'm not making use of years as my x. My x is deviation in years. So 2015 is being represented by 5, 2014 is being represented by 3. Let me check. 2016, 2017. If I go with this philosophy, 13 is 1, 3, 5, 7, 9. My 2017 would have been represented by a 9. So what I'll do is, instead of this x, I'll put 9. So I get y for 2017. What is it? 60 plus 4.979, which if you further solve comes out as y for 2017 is equal to 60 plus 44.74. So I can say that which when solved is 104.74. So I can say expected sales in 2017 are 104.74 multiplied by 1000. Why this 1000? Because all the values are given in thousands. So my expected sales would be 104740. You can expect to sell these many units in 2017. Instead of 93, I'll be able to sell 104. And to be precise, if you talk in terms of thousands, it will be 1,04,740 because these values were in thousands. Okay, so this will be my answer, 104, or to be precise, 104740. Or if you find it difficult to express this way, you can write 104.74 in thousands. Anyways, you can represent it the way you are comfortable. Thanks for watching. Bye bye.